Okay, so this is a second video on the practice quiz pre 2.6 where we talk about domain range, the linear equation in slope-intercept form y equals mx plus b, and its condition, which is technically its domain. Let's jump right in. Starting with question 17 on this video, it says, given that g of x equals 3x plus 4, find the range values that correspond to the domain values. So the key words here are range and domain. Okay, so we need to remember from our notes or from class that the domain values are the values that go inside the function machine, right? This function, g of x, it's called g of x, but that's just a name. It could be like a y, could be h of x, could be f of x. This is just function notation. That's the name of this machine right here, this function machine. So, for example, if I told you use 5 as an input, what are you going to do with that 5? You're going to put it in right here where the x's are at. 3 times 5 is 15 plus 4 is 19, right? So the input 5 gives you the output 19. So I think we understand that. But right here, they're asking, they're using these fancy words range and domain, and hopefully we already understand them and are comfortable with them. It says find the range values. So what are the range values? I hope we remember from our notes. We have a machine. Let's just say it's a box, and let's say there's the input, here's the output. So you put the 5 right in there, and out comes the 19, right? The value that goes in, that's called the input, okay? Which I misspelled, sorry about that, input. The value that comes out, that's called the output, obviously, right? So where do we put in the 5? You know, we should probably, let's go back up here. Where do we put in the 5? You put it in right into the x. So the input values are also known as the x values. And the answers that come out when you plug in a 5, 5 times 3 is 15 plus 4 is 19. This is technically like a y, so it would say y equals 19. So your outputs, that output of 19 is also known as your y values, or your y value, right? And in addition to those, we should remember that the input, or the x values, are called the domain values. Okay, and the outputs, the y values, they're also called your range values, range. Okay, so keep in mind that domain means x values, range means y values. I mean, technically it also means input, it also means output, right, for the y values. But anyways, what are they asking for right here? They're asking for the range, so they're asking for the outputs, okay? They're asking for the answers, the outputs, okay? That correspond to the domain. What are the domain? The domain are the inputs. So they're wanting us to put in these values into the machine. So let me clear this up and show my work. The function notation for me plugging in the number 2 into this g of x function, the function notation is this, g of 2. Now you don't have to write that. What really matters is actually plugging it in right here where the x is at. So here we go. We have a 3 times 2 plus 4. Okay. So what is 3 times 2? That's 6. And what is 6 plus 4? That is 10. So g of 2 gives us 10. All right, let me go with the next one. Let's plug in negative 5. Okay. So plugging in negative 5, that's going to be g of negative 5. That will equal, we have a 3 times negative 5 plus 4. Let's write that out. 3 times negative 5 plus 4. So let's do the multiplication first, right? 3 times negative 5, what is that? That's negative 15. I'll write it right here below, negative 15. Bring down the plus 4. Negative 15 plus 4, the answer is negative 11. Okay. And last but not least, let's plug in the last domain value, the last input. They want us to plug in 0. So we're going to plug in that 0. So I will again have this exact function, 3 times 0, I'm plugging in a 0, plus 4. So that's what I have here, 3 times 0 plus 4, plugging in that 0. So what is 3 times 0? It's 0. You could just scratch it out. What's 0 plus 4? It's 4. Okay. So I want to use colored highlighters here. The domain value of 2 gave us 10. Okay. The domain value of -5 gave us -11. And the domain value of 0 gave us the range value of 4. Okay. So what are the range values that correspond to the domain values? We're just going to make a list. We're going to write it out. The range values are, you can just put in the answers in order. And that's your answer, 10, -11, 4. Those are the corresponding range values for the given domain values. That was a long explanation, I'm sorry. On this question, they're asking us to select the following words that mean the same thing as x values. Okay, so what are the x values? It might be good to go back to our notes here. And this is from the first part of our notes, 2.6a, domain, range, and piecewise functions. Remember, we talked about the machine. Every value that you plug into the machine, like let's say I plugged in the number 10 and it comes out as 21, or I plug in the number 5 and it comes out as 11, or I plug in the number, let's say 50, and it comes out as 101. I hope you guys see that the machine that's producing these outputs for those given inputs are y equals 2x plus 1, okay? So that makes sense, right? Plug in 10, 2 times 10 is 20, plus 1 gives you that 21. The 5, 2 times 5 is 10, plus 1 gives you 11. The 50, 2 times 50 is 100, plus 1 gives you 101. So I hope that makes sense that this machine is the function y equals 2x plus 1. Anyways, back when we did this, we said that domain, inputs, x values all mean the same thing. Those are the values that are going into the machine, and the values that come out of the machine are called range, output, or y values. Okay, so we need to understand that the 10 could be called an input. Why? Because we put in the 10 right there. It could also be called an x value. Why? Because we put it into the x, right? The inputs are the x values. And we also have this fancy word domain, that those are the same thing as inputs and x values. So what does our question say over here with regards to that? It says, which of the following mean the same as x values? We just said that the x values mean the same thing as domain and also inputs. And that's about it. So you would select those two, hit enter, and you get the right or full credit. Okay, let's move on. On this question, we have, again, the vocabulary word domain. And what does domain actually mean? Back to the notes here. Domain means inputs and x values, okay? So if they're telling you to state the domain, they're really telling you to state the inputs. Now, that might not make too much sense because you don't actually see a machine that you're plugging in values and pulling out answers, but domain also means x values. And on each of these coordinates, you have both an x and a y, right? You have a x value and a y value, an x value and a y value, an x value and a y value. So if they say state the domain, they're really telling you to state the x values. So what's the domain? It's 3, 5, 1. 3, 5, 1. That's their domain. 3, 5, 1. Let's move on. When we state a piece of a line, we give the original function in y equals mx plus b, but then we state its condition. The condition is technically the blank of the piece of line shown on the graph. That's a lot of words. Let's actually take a look at what that looks like in action in math. We did an entire worksheet of these where I give you a piece of line and you need to state its function and the condition that it must have in order to show this piece. So let's all begin by remembering that we want to graph this, we want to get this equation by writing an equation in slope-intercept form. So we need those two things. You need the slope and you need the y-intercept. So you could clearly see the slope by picking two nice points like this one and that one and see how much you actually rise from left to right and how much you run. So as you can see, you're going up 1 unit and over 2 units. So the rise over run is going to be up 1 unit over 2 units. So the slope is positive 1/2. Now, what is the b value? The b value is where it crosses the y-axis. Here's the y-axis. So where does this line cross the y-axis? Well, it doesn't, but you got to pretend that it does. So let's continue with the same pattern of going up 1 over 2, up 1 over 2. You see the original line, the complete line, this is only a piece of the complete line. The complete line really would cross the y-axis right here, right? I mean, if you wanted to, you could just like extend it, and that way you could see that the b value is right there at 5, okay? So now that we know the m and the b, now you could write your y equals mx plus b equation. Y equals m 1/2 x plus b plus 5. And that's your equation. That's your y equals mx plus b equation. But of course, that equation produces the whole line going infinitely that way and this way. And we need to give it a condition to not actually show this part, only to show from here to the left. Because remember, the condition is always talking about the x values only, not the y values, all right? So let me go back and erase this, okay? And let's state its condition. So the condition is, here's our equation, and we're going to say if your x values are where? So does this line exist at 0? No, it doesn't. Does it exist at -1 on the x? No, it doesn't. Where does it start existing? It starts existing right here at -2. Well, technically it's an open dot, so it doesn't really exist at -2, but we know it exists to the left of -2. So if it were a solid dot, yeah, you would say x is to the left of -2. You'd say x is less than or equal to -2. But it's an open dot, so you're just going to say x is less than -2. So the condition is if x is less than -2. Okay, so that's your function with its condition. Okay, again, the condition is pretty much just your domain value of what you see here. Okay, so like let's go back to the original piece of line. Let's ignore everything else. If I were to ask you what's your domain value, you would say x is less than -2, because this piece does not exist at 1 or at 3 or at 5. It doesn't even exist at -1. It's right here at -2 and to the left of it, right? It's at the x value of -2 and to the left, so the domain is x is less than -2. Now if I asked you, how about your range? What's your range? Remember, the range are the y values. So does this graph exist at the altitude at the y value of 5? No, it doesn't. It starts existing at this value below, right? Or below this value. What is this value? It's 4, right? So right here at the altitude of 4, the y value of 4, but it's an open dot, so you can't really include 4, but you know it's below 4 because this thing goes below the y value of 4. So range is y is less than 4. So notice that the condition, the x is less than -2, that really is pretty much your domain. Okay, so I hope we understand this. Now when we look at the original question, it reads, when we state a piece of a line, we give the original function in y equals mx plus b. Exactly, we figured out the m and the b, we stated the y equals mx plus b equation, but then when we state its condition, What is the condition? The condition is technically the blank of the piece of line shown on the graph. We just said that the condition is the domain. So that's a word that belongs right in there, domain. So you guys should type in domain, hit enter. Another acceptable answer would be the x values, or another technically another correct answer would be the input values, right? Or the inputs. But I would just put domain. That's the most clear answer there. The condition is technically the domain of the piece of line shown on the graph. I hope this helps. I will see you in class.